Um, Hello, everyone. Thank you for joining us. My name is Joao. I'm a senior technical manager at Viator, where I lead the mobile engineering teams.
Hey, George Corn Lisbon. I'm Adam Law, senior software engineer at Viator, iOS lead, and head up the platform team on mobile.
Hi, I'm Ricardo. I'm senior mobile engineer and also tech lead for the Android platform.
All right, so if you're not familiar with Viator, we are a market leader in travel experiences with over 300,000 experiences for you to explore in our app. You can find everything from tour guides to extreme adventures. Actually, if you're staying the weekend in Lisbon, we have quite a lot of products in Lisbon, so if you're looking for something exciting to do, feel free to use our app. I lead dedicated teams that work on mobile development with over 20 people, most of them software developers, Android and iOS, and distributed across 7 countries in Europe. Also here in Portugal, we have an office here, and some of our engineers are based here in Portugal. We've been, for the last 3 years, developing the Viator mobile app, based on native technology, so on Android and on iOS, and using a fairly modern tech stack. So for example, on Android, with Kotlin, coroutines, Jetpack Compose, powered by a GraphQL backend. So recently, we started to look into expanding mobile engineering into other already existing multifunctional product development teams that we're doing mostly web and backend. And with that in mind, we are now starting to shift focus of these dedicated mobile teams from product development into platform development. So what do I mean with platform exactly? I'll leave that for you guys to read. I won't read through all of it. There's a QR code that takes you to an article where that definition was coined. I think it's a very good definition. But taking some key aspects of this definition, so if you think about this set of tools that are organized as a product, that will help other engineering teams to self-serve and deliver at a higher pace, you probably realize that, in a way, we are already doing that. Probably you guys are already doing that in a way or another, because we inevitably have to build the tools in our code base to support the feature development that we need to do. So, but if you think about it, like, are we really building platform in a way that others can self-service, in a way that we remove low-level knowledge from the engineers that are building product features? We remove cognitive load. These platform tools are actually empowering, helping, enabling these other teams, these other developers, to move faster, to build better products. And the answer, at least for us, was, well, kind of, but not really. So that's when we started looking at this concept of platform as a product, with the goal to solve those problems and actually become more efficient. Any product needs customers. So who are the customers for this platform that we want to build? I kind of gave that away. That would be other product engineering teams that are focusing on building the user-facing features. I mean, primarily because you could look for other internal and external customers for this platform. Especially if you are in a part of a bigger group like we are at TripAdvisor, there's other mobile teams, so there would be opportunities there to find other customers. But for the sake of time, we'll just focus on these other product engineering teams. So we are building native applications on Android and iOS, and that means that if you're going to build platform as a product, it needs to be consumed by both platforms. So that means that you're actually building twice the same product, Android and on iOS, different code bases, different tech stacks. So more expensive, takes longer, more complex, not ideal. And that's when we started also looking at Kotlin Multiplatform. Because we're not trying to rebuild our app from the ground up with multi-platform technologies. We're trying to build our platform with multi-platform technologies so we can just maintain one code base and have these tools be consumed by Android and iOS alike. So we are at the very early stages of this journey, and we would like to share that journey with you guys. Hopefully, through this session, you'll learn about the challenges we faced, the mistakes we made, so you don't have to. Adam?
Thanks, Joao. So, yeah, why did we choose Kotlin Multiplatform? There's a ton of cross-platform frameworks that we could have chosen. Too many to kind of go into for this talk, and it's not the topic of this talk anyway. But I just wanted to cover some of the main reasons why we thought Kotlin Multiplatform was a good fit for us. So, yeah, the first one is that your apps remain native. So we already have native apps. We don't really want to depart from having native apps. So all the app code remains native. So Kotlin JVM compiles down to Java bytecode that runs in the JVM, unsurprisingly. But iOS doesn't have a JVM. So Kotlin native compiles down to a native binary on iOS. And the practical upshot of that is there is no performance trade-off. It's not like this is native, but there's a JavaScript bridge which you're going to get caught out on with performance. So, you know, the Viator app is fair to say it's not a performance-critical app in the way that like a game is. But we didn't want this sort of venture into a cross-platform to come any detriment to the user experience. And so, obviously, performance is a big one there. So any cross-platform framework in the grand scheme of things is kind of a high-risk investment. It changes the way that we go about writing code and obviously sharing that code. But in the grand scheme of things, Kotlin Multiplatform presents a low risk because it's not an all-or-nothing approach. You can go in and you can share the smallest amount of code, and you can prove that out, gain confidence in it, and then you can go on to share bigger things. So in our particular use case, we wanted to keep the UI native. We love Swift UI, Jetpack Compose, and well, at least in the case of iOS, we didn't want to depart from Swift UI. So we decided to keep the UI layer at where it was, and we looked at other areas that we could share code. And then another big thing, of course, it doesn't require an app rewrite. And in the case of the projects that we've got, the two established projects, we've got a mature Android code base, which in many cases, we can take the Android code and we can rework that into KM with like little to no change. So that's a huge win for us as well. Language interop. So I mean, obviously, KMM just works seamlessly on Android, unsurprisingly. But even on iOS, the interop with Swift is pretty fluid. It works well. It does use Objective-C as a bridge. So some of the Kotlin language features do get lost. But there are sort of ways around that, and one of those is a Sky compiler plugin, which really kind of improves things there. We'll touch on that a bit later. But in addition to that, technically there's no reason why there couldn't be a direct interop with Swift. It didn't make sense to do it at the time, because the Swift ABI was not stable, so it would have been a world of pain for JetBrains to do that direct interop off the bat. But it's something that they said that they're going to be working on. So that's going to really improve this area even further. And then, familiarity. So obviously, Kotlin's super familiar with all of the Android developers. It's a language that they obviously specialize in and able to offer support with for iOS developers kind of wanting to get into this. But also as a language as well, it presents like a less of a learning curve for iOS developers because it is quite comparable to Kotlin in many ways. And then finally, developer satisfaction. So it was like 98+% satisfaction score from like a 2001 survey that I think JetBrains did. And it's evolved massively since 2001. So the future for Kotlin Multiplatform is really vibrant right now. And obviously this year at Google I/O we're seeing Google now supporting it as a first-class citizen. So we're going to see Kotlin native support turning up in more and more Android APIs going forward. And I think on yesterday's talk, John O'Reilly, you saw the number of libraries that are available in Kotlin Multiplatform. So it's a good time to sort of jump in and take the plunge. So with that, I'd like to hand over to Ricardo to summarize our journey so far.
Thank you. Okay, about our journey. So we start when thinking, when can we share our code? Because one of the patterns we start to notice is in both platforms we have the same code and logic, especially when, for example, we are fetching data, and it's like we are when reading the code twice. And with this thought, maybe we can create a proof of concept. So we select KMM. Maybe we can learn a bit about this platform and how it behaves. And after, maybe we can rework an existing feature. So we select the logging. Logging is the simpler feature when we have. Is the logic is simple, it's easy to use, also it's safe. And we can even reuse the code what we have on Android, so was a good candidate. But this implied now we have a third project. Now besides the iOS, Android, and now it's a third one we need to start managing. And after this step, we start rolling out in production to see if it's safe for production. This was behind of a feature flag. In case something goes wrong, we can always disable and replace for the old one. And also see if there is any impact on the app when binary. Our sample was like a few kilobytes, so it wasn't a big deal. After this, we start looking. We need to take the decision: should we use it? And we need to look for, need to evaluate what was the challenge, especially the challenge. It's where we want to talk a bit more. Nothing is perfect, and we found some challenge for both platforms, especially for iOS, and this is where we want to share our perspective as another developer, what you can expect when you try to use KMM for both platforms. Adam?
Thanks, Ricardo. Yeah, so the first thing I wanted to talk about was CI/CD. So the out-of-the-box behavior when compiling Kotlin Multiplatform is you can get an Xcode framework locally, but that's kind of where it ends. So obviously, if you want to take this into production, you want this going through CI/CD, a proper pipeline. So we decided at an early stage to adopt Cambridge. It's a Gradle plugin from the guys at TouchLab. And yeah, the big kind of benefit that offers is that it handles a lot of the iOS publication, so supports CocoaPods and SPM. Because the SPM publishing is quite tricky, the setup of Cambridge is also quite fiddly too. So fortunately, they provide a template project with all of that configuration set up. So it offers like a really quick way to kind of bootstrap your project and get that working through CI. So in addition, that template project provides a couple of GitHub publish actions. So a publish action for iOS, and then a publish action that publishes both iOS and Android. So yeah, we use those publish actions, and then on top of that, we added a basic pull request workflow that just runs the full suite of unit tests and acts as a gate for mergers. So we got all of this set up, yeah, pretty smoothly. The only slight thing for us was that we use GitLab, and all of this is set up for GitHub. We didn't want to kind of invest a ton of time at this stage kind of reworking that into GitLab. We wanted to spend the time instead on the actual project and what the integration looked like back in the respective projects. So as a short-term thing, we just set up a free GitHub tier account internally, private, and we used that. And all was good. We got the first version of the library kind of in a state where we were happy to integrate that back into the projects. So we did some workshops with all of the development team, because there's a bit of project, like one-off project setup that you need to do. We went through that, and we got the library integrated back into both apps. So yeah, happy days, all good. And that's kind of like roughly the time when I packed my bags and I went on holiday. But, there is a but. Shortly after I left, all of the builds in CI started failing. So both iOS and Android builds. This is a snapshot of one of the failed Android builds. Artifact not found exception, which is funny because the artifact hadn't gone anywhere. It's slightly misleading, but turns out that this was a usage quota issue. So yeah, we hit the free tier usage quota on GitHub packages, which is kind of unfortunate, but yeah, it's not super clear from that exception what it is. On reflection, I kind of think like, if you left the house in the morning and you'd forgot to pay the mortgage, when you come back home, would you find that your house has miraculously disappeared and there's just a void of land? Probably not. So yeah, there's probably a more useful message that the guys designing that API could give for that. But like the short-term solution that we took here was just to move the artifact to Artifactory. But it worked. So we manually deployed in the short term to just unblock the builds. And then, we took the opportunity at that point to do the migration to GitLab, which we'd kind of always planned to do anyway. The support for GitLab with Cambridge, they'd recently added some publishing support. We were using a GitLab on-premise, which it didn't support, but we've added support, and we submitted a merge request, and that's gone back into the library now. So yeah, long story short, we just have everything migrated to GitLab now. And yeah, I guess the learnings from this are, well, if you use GitHub already, it's a no-brainer. Just use those actions, at least initially. But even if you don't, you can set up a free tier account, and you get a Mac runner for free as well, so you're not burning any CI time if that's precious to you whilst you're in these early phases. But if you do that, obviously just, take a look at your usage to make sure you don't have any unexpected surprises. So on the topic of boom and bang, I'd like to hand over to Ricardo to discuss crash reporting.
Okay, about crash reporting. Well, one of the challenges we found, especially for iOS, it's the stack trace. So in case if there is a crash inside of the KMM library, you just see this Conan abort, and that's it. For iOS developer, you don't have any kind of context. So to simplify this, we are using this one library. It's called crash bootcamp on iOS. What it's doing, it's a symbolic representation of the exception. So in this case, this is like you can see on the Crashlytics, you have all the information of the Kotlin class inside of iOS. This helps a lot, especially for iOS developers. Android doesn't have this issue because it's this but behaves like a normal dependency what we see on Android app. And this Crash KiOS supports Bugsnag and also Crashlytics, but still needs to be initialized on the client side to work. Error handling and propagation. So this was found by accident. We are using this library. It's called Sky. KMM only expose Kotlin to Objective-C, but this one Sky allows to convert Kotlin to Swift directly. It supports Mozilla class, enums, suspend functions, and also flows. This is a small example. Flow done in coroutines can be exposed as a sys combined easily, so it's easy to use. For our surprise, this Sky doesn't propagate the exception. So for some reason, exception is thrown inside of KMM one library. Okay, let's wrap with a try catch inside of the iOS side. This is a small example of what is happening, and for some reason it doesn't catch anything. And we notice the app was always crashing because this exception is never propagates. One solution is to wrap the result the error state. But even Kotlin has the result class like Swift. The result class is a value class, and the value class is not supported by KMM. It can be exposed. So ideally, it's to wrap with your custom result class. Yeah.
So yeah, on the topic of local iOS development, yeah, I appreciate this is an Android conference, but obviously we do have to talk about some of the iOS things because you know the success or failure of any cross-platform thing, you know, lives and dies by like how well it integrates with all the platforms. So yeah, we chose a remote published workflow, so traditional workflow. So we build features into the library and then publish those remotely, and then consume that back into both projects. And there's a few kind of good reasons why we did that. Firstly, Cambridge provides a remote workflow out the box. Android can still consume a binary locally, or you could even publish to Maven local if you need to. But importantly, like iOS can consume the library just like it would any other dependency. So it looks just like any other dependency. And we use the Swift package manager to do that. And then also, iOS developers aren't forced to have to jump into Android tooling, so they don't have to pick up Android Studio to like compile the code and then embed it or anything crazy like that. But there are a couple of like downsides with that approach. So the remote workflow can be a bit slower because you kind of got to make the changes, publish them, version them, integrate them back, and then if you find out something's not quite right, you've got to go back around the cycle again. And then iOS developers have got to go to a separate repository to make those changes, which I think in the scheme of things is kind of acceptable anyway because that's sort of inevitable. With any cross-platform approach, it's inevitable you're going to have another repository. It just makes sense. So, like, you know, one of the obvious questions that comes up from this then, from the kind of iOS perspective, is, well, you know, I want to make some changes to the library, but I don't want to have to publish them, integrate them back, just to find out they didn't quite kind of work as I was anticipating. So, is there a local development workflow that can be done on iOS as well? And yes, there is. It's not super straightforward. There's a bit of black magic to it. But just before that, you know, obviously, like, we should be covering the code in unit tests anyway. So, like, the unit tests should give us a good baseline confidence in the code that we're writing is behaving as expected. But then in addition to that, in the KMM project, we added demo apps for iOS and Android. So you can run up those demo apps, and you can see the library kind of integrated back into a sample project with a bit of UI. So that's great for, like, just obviously demonstrating the functionality of the library, but it's also good for kind of teasing out any potential integration issues with the library back into, like, a skeleton project. But, you know, there are times still when, like, ideally we need that same local development approach on iOS. Unfortunately, Cambridge provides a workflow for that. So basically a Gradle task you can run, SPM dev build. That builds the project in debug, and it updates the Swift, the package.swift file for iOS to point to your local directory. And then with kind of some slightly strange, got to drag it into Xcode, and it replaces the remote with the local, which it kind of does by itself when you drag it in. Once you've done that, you can build the iOS project, and you're running from a locally built library, which is great. The only slight snag is when it comes to debugging, there's no, like, debug support. You can't set a breakpoint, can't step, can't see like variable information. So fortunately, Touch Labs have also produced an Xcode Kotlin plugin. It's got a CLI aspect to it, which basically downloads the plugin, and you can run it when you get a new version of Xcode to kind of reintegrate it, and it keeps the plugin up to date. But essentially, this plugin gives you, like, the holy grail, which is full debug information. So just a screenshot there, you can see the full call stack, set a breakpoint, line stepping, all of the variable information. So yeah, this is, you know, debugging, and you can even change the Kotlin code in Xcode. So, like, this is a bit of a game changer. It makes a huge difference. And so that's where we've kind of left things in terms of the approach that we have on iOS. It is, however, worth mentioning, because, like, this whole area is moving so damn fast. Only like a month or so ago, TouchLab produced a Git portal tool, which actually, instead of publishing the library in a traditional sense, you don't publish it at all anymore. It kind of acts as a Git submodule, and you pull back a versioned code back into both projects, and then you can skip this entire local dev workflow step on iOS. So it makes the experience even slicker. The tool's only in alpha. We're going to certainly be keeping an eye on it over the coming months. But for anyone kind of approaching this now, I definitely recommend that you check that out. Back to Ricardo to discuss Apollo.
Apollo, it's a GraphQL client, it's now when they are also supporting KMM. It's powered by Kitor, and Apollo provides its own cache mechanism. It can be memory or SQLite database. And this is also powered by SQL Delight. And we found some linker errors because on iOS especially, some functions were not defined. And this was surprising because what we noticed is SQL Delight is supported by Android natively, but not for iOS. iOS needs this SQLite 1.3.h as a source file. And since this is external source, needs to be linked on the build phase during the next code. Apollo can link this automatically, but there is a small caveat we found. This only works if it's a project. But if it's a package on for Swift, it's the same thing like we have as a dependency, and we need to specify on this package .swift is the same is the metadata for the package, and we need to it has all information about this dependency, and we need to specify especially needs to link SQLite 3. Or the Xcode doesn't know this package as another framework inside, in this case, for Apollo SQLite. So it can't work.
So one of the kind of more recent issues that we ran into, so we had a bit of shared states. And we had an issue on iOS, basically. We were consuming some code in a slightly different way to how we were on Android. And we were consuming it in like an asynchronous context. So we had a race condition. So we needed to basically shore up that code. So it was guarded against that. So, if this was in a coroutine, then, we could use the Mutex APIs to delimit that section and suspend the coroutine. And I know the coroutine support in Kotlin Native has come on a lot since the new memory model. I think coroutines now run on multiple threads instead of a single. So if you're using coroutines, you're in a good place. But in this case, we weren't using a coroutine, and we wanted, we needed to do like a traditional block. So couldn't use synchronize because that's part of the JVM, so not available on Kotlin Native. So there's a couple of kind of options there. So a couple of third-party libraries. I mean, I say third-party. The first one, Atomic Foo, is actually a JetBrains library. And the second is a TouchLab one. They basically provide concurrency primitives and collections. We use the Stately library because it's just kind of a lot simpler, a lot smaller, and it kind of fit our needs. And just kind of an example here using the Stately library. You can inherit from synchronizable, and then you have access to the synchronized functions, which you can use to wrap the critical sections. So the code looks really quite kind of similar to how it would if you were just writing Kotlin on Android.
And our final challenge was the minimum iOS version. So in this case, it was for our surprise when we tried to publish our iOS app on the App Store using one with the KMM library. The app was rejected, and the reason was is the Monero framework for iOS needs to have the minimum iOS version specified on the file info one plist. This is also behaves like a metadata for a dependency. And so in this case, on the KMM project, we need to specify on the compiler arguments to write the min version for iOS. So when on the build time from the KMM, we can show, you can see this. And after this, we're able to publish it on the app. Not any issue. Sure.
So then just to wrap up, so yeah, next steps for us then. So yeah, the iOS developer experience remains a key thing. I think we've got to a point where it's as good as it can be for now, but there are improvements that could be made there. Perhaps with the use of this Git portal tool, we can kind of take that a step further. So we've got our first module in production now. So we refactored all of the logging module into KMM, so that handles all the development logging from standard out to kind of in-memory logs when developing. And that also takes care of all the crash reporting as well through Crashlytics. We've got a new use case for logging. We've got an in-house platform for remote logging. So we're going to write a remote log writer, and we're going to plug that in using Amazon's Elk stack. So we've got some interesting work coming up there. But obviously, yeah, we want to get to work on our first new module built with KMM from the ground up, and we've started work on that already. Got quite far into it. So we use Firebase for A/B testing. Everything that we do, we A/B test, and we've kind of outgrown that now. And we've got an in-house solution for A/B testing that is going to allow us to run A/B tests from web across to mobile. So it's going to kind of relieve some of the issues that we have with kind of being confined to Firebase. So yeah, we're going to add a Viator experiments module, and we're going to build that in KMM from the outset. And I think once we've delivered that, then that is kind of marks a good point to kind of take stock. Look at what the benefits are, gauge kind of developer sentiment, and really kind of see like, is this stacking up to what we thought it would be? Are the development savings kind of what they are? How does everyone kind of feel about like the development flow as it now stands? But ultimately, kind of unsurprisingly, aspiration is to refactor loads more things. We've got a ton of use cases from like utility things like analytics through to like networking and the data layer. We've got like we're following clean architecture in the project, so it makes it quite nice to be able to kind of draw a line and decide like what you want to essentially bring into KMM. So that's where we're headed next. Got some interesting work ahead of us. Over to Joao for some closing thoughts.
I'll move to that side. It's okay. You guys can stay. Thank you, Ricardo. Thank you, Adam. So, if you find this concept of platform as a product and developed in Kotlin Multiplatform interested, and if you'd like to join us on that journey, we'll soon be hiring for multiple positions on mobile development, both on Android and on multi-platform. So keep an eye on our careers website, or if you follow that QR code, there's like a simple form where you can leave your interest, your contact, and we'll get back to you. So wrapping up, if at any moment you had the impression that we attended the wrong conference just because of all these references to iOS, we didn't. If you look at this conference alone, just the number of sessions that touch Kotlin Multiplatform, the fact that you guys are here shows that the community has quite some interest in developing multi-platform using Kotlin. And you guys, as talented Android developers with Kotlin experience, will be the more likely candidates to take on that task. And what we learned through this journey thus far is that you guys will find no challenges or very little challenges building your platform with Kotlin Multiplatform and running it on Android, something that you're familiar with. However, if you're trying to build multi-platform, chances are that you want to build it for other platforms as well, like iOS, and there's where we found that everything that you learned today. So in that sense, if, like us, you're trying to solve the same problem, and you have a similar setup, you have Android engineers, iOS engineers on your teams, just bear in mind that there will be these challenges. Do involve the iOS engineers building multi-platform, and roll up your sleeves and help them overcoming those challenges. If you guys have any questions, any comments, or if you want to catch up with us, we'll be around all day. And we're easy to spot by the matching t-shirts. So yeah, we would love to talk with you. Yeah, just approach us and we'll get to know you. Thank you, everyone.